Hi, so back again for another video. In this particular case, we're going to look at a loop circuit, and so excuse the thunder and lightning. That's, um, yeah, and the other thing, just on a side issue, is I've included animation in the acronym SCAD DTS, so it just fits nicely. So wasn't sure what to do with the A. Anyway, so if we log in and if we select the loop circuit this time, and there's only one project associated with the loop circuit, so it's the loop system. And if we select the circuit, then we'll get the circuit diagram, the nodal diagram. Yeah, note that the engine is subcooled, and the fluid is water and the gas is air. So if we look at the circuit, you can see that we have 4 tanks. For tanks 1, tank 2 and tank 3, the links are on the leaving side. That's on the basically the base of the tank. So it includes the head of water for each tank. This might be a bit confusing, but it's the reverse. So, and in the case of tank 3, then the fluid is entering the link. So that's the difference between the two. As far as the pumps are concerned, we have pumps between nodes 1 and 2, and between 2 and 8, and between 7 and 3, and between 4, between 4 and 6. And then we have loop circuit. Remember that the link index is the one with the open and closed chevron, and the node index is the one just closest associated with the small circle. Okay, so if we go back to the circuit page, and then we select the circuit, having selected it there, then we come to the circuit control page, and bear in mind that there's a one-to-one relationship between the circuit and the control page, so we have just the one record, and it's on the controls page that we can select runtime and then start the simulation. So just a side issue, if at any point you change the topology of the circuit, then you have to save the model, and this is where you save the model. It says, please confirm that you want to create a new node, links in and links out object set. This will delete all node data while retaining link and device data. Since we haven't started yet, so that's okay. Okay, and as I say, bear in mind you have the 3 pumps, and you have the device IDs associated with each of the pumps. So, going back to the control page, and we go back, if we need to select the circuit, and then go into runtime. Now, as you can see, the pressures are shown here, and the links are shown here. So we've got the flow rates and we've got the pressures. If we go to the control page and go to the tanks, then we have the 4 tanks, tanks 1, 2, 3 and 4, and you can see the this is the initial percentage mass in the tank based on the dimensions that we have here. So the width, length and height, that defines the dimensions, and this is 75% of that according to the density of the fluid. This is the index of the link in for tank 3. So I don't know if you remember, it was link 7, and then the ones out are links 1, 4 and 10. If you can go back to the circuit, so 7 is going in, and 1, 4 and 10. 4 is out, that's the link, 1 and 10. Okay, so again, going back to the circuit and going back to the links. Okay, so what we can do is now, if we go to the controls page, and then, no, not the controls page, to the circuit page. Circuit page, bring the circuit diagram up, and then we'll just annotate this with some blocks of data. So for instance, if we look at the tanks before we do anything, and it'll be tank, say 1, and submit. So that mass is dropping. Tank 2, and that mass is also dropping. And tank 3, and that mass is increasing. Okay, so 0.74, 0.69, tank 4. Okay, so tank 4 is dropping off as well. That implies that each of the pumps is actually operating, which is the way we set it up, or at least the way I set it up. If we look at the pressures, then let's say we look at the pressure on node 5. That's 53.82, and let's say node 7. That's 40. So you got a 13 psi pressure drop across the loop. Let's just check, and then a link. Oops, 7. Yeah, that was 7. Okay, so this is the link. So you got flow rate of 2.549 pounds per second going into node 3, which goes into the top of the tank. Okay, so alright, so what we could do is, let's say we stop, let's stop tank 2. We'll see what happens. So if we go into links, and the link index, so the design index for node, node 2? Oh, I've forgotten. Okay, so yeah, we want to stop the pump on link 2. So go back to links, and link 2, that's the pump, and if we select it, we can see that it's starting, and that's the flow rate. So if I stop it, so the dynamic head goes to 0, the admittance still stays constant. And if we go to the circuit page, bring up the system, and let's say we look at link 2, we can see that it's negative. So this pump has stopped, but there's still a flow rate going back through the pump, and these pumps are actually operating, so they're supplying pressure. If we look at the pressure at node 5, it's now 35.54 psi, and so it's still higher than this pressure, but if we look at node 8, let's have a look at node 8. Not node and 8. Oops. Okay, so you got a pressure of 44.4887 psi, and so you've got a reverse flow going back through into the pump. Now, yeah. Still, the tank 3 is still increasing. So irrespective of this pump. So let's have a look at this pump, and then we'll do the same thing here. So let's stop the pump on link 5. So if we go to link 5 and go to the pump there and just stop it, that goes to 0. And if we go to the circuit and then circuit, and then so this pump has stopped, and let me see the flow rate. The flow rate on 5 okay, so it's negative 0.626, and you can see that by the tank increasing in mass and the level increasing. So you've got negative flow here, negative flow there, but a positive flow through here, and so the tank mass is dropping off more severely now. We're halfway, and this is increasing with the reverse flow, and this is still increasing. So that's it for this video. Thanks for watching.